Question 22. The graph shows the populations of two different animals, W and K, in a conservation park over time. The y-axis is the size of the population and the x-axis is the number of years since 1985. Population W is modelled by the equation y equals a times 1.055 to the power of x. Population K is modelled by the equation y equals b times 0.97 to the power of x. Complete the table using the information provided. Both equations are instances of exponential functions because the index in both equations is the independent variable x. Now x represents the number of years since 1985. Let's look at population W. It's modelled by the equation y equals a times 1.055 to the power of x. Notice that the base is greater than 1. What that means, as x gets larger, y will get larger. So population W is increasing as time goes on. And it's modelled by this curve here on the graph. And I've labelled it here with a W. Population K has a base that's less than 1 but greater than 0. As x gets larger, y is getting smaller. So the population of K is decreasing over time, and I've labelled that as such. Now when x is 0, 1.055 to the power of 0 is equal to 1. That means in 1985, y is equal to a, and that represents the initial population for population W. Same thing goes for population K. When x is 0, that represents the year 1985. 0.97 to the power of 0 is 1, so y is equal to b, and that represents the initial population of population K. And that corresponds to the y-intercepts of both curves. So here's A here, and here's B. So let's proceed to complete the table. Now it's given that the initial population in 1985 for population W is 34, and that corresponds to the y-intercept here. Now if we look at the y-intercept for population K, so that's this decreasing curve, at this point here, it corresponds to 280. Let's look at the percentage yearly change in the population. And we consider the bases of both exponential equations, which I'll go back to the original equation. So the base for population W is 1.055, and that can be written in percentage form as 100% plus 5.5%. So if you add those two together and convert it to decimal, we get 1.055, and that corresponds to a 5.5% percentage yearly change in the population, and I've noted that here. Now the base for population K is 0.97. In percentage form, that can be written as 100% minus 3%. We do know that population K is in fact decreasing, and that corresponds to a negative 3% decrease each year. Lastly, to find the predicted population for population W, we can use the equation. So we have y is equal to a times 1.055 to the power of x. So when x is 50, we substitute 50 for x here, and we know the value of a, which is 34. So when x is 50, y is equal to 34 times 1.055 to the power of 50, which equals 494.4266 and so on, which rounds to 494, correct to the nearest whole number. And I've written that